Hey class, this is Chapter 5, IT Infrastructure and Emerging Technologies. I've used WebEx for the first few videos. We're trying Skype today, so we'll see how it goes. So this week we're looking to see what IT infrastructure is, what its components are made up of, what are trends in hardware and software, and challenges that go into managing IT infrastructure. Our cases for the week are Rockwell and ESPN. We did not have to do the Netflix case. The ESPN one is one I would typically show if we were having class on campus for both sections, the one on campus and the online one. So we're not having the online class, so we don't get to see the ESPN together, but we may talk about it in class. So what is IT infrastructure? It's a set of physical devices and software required to operate an enterprise. It's computing platforms, physical facilities, management, and users. And we'll talk more about what makes up your laptops, your desktops, servers, and the like as we go through the chapter. So as we can see from the slide, there's a connection between the firm, infrastructure, and capabilities. So let me make my screen a little bigger. We see information technology, strategy, and business strategy on the left of the slide, how they're all bidirectional and they interact with each other. What's providing inputs and outputs are our services and infrastructure. We really can't have an organization that's digital or IT friendly without having an infrastructure. So how did we get here? How did we get to where we are right now in 2019? Well, our first mainframes happened in the late 1950s, early 1960s, and are still present today. In fact, Watson, what we have our entire semester project on, is a type of mainframe, cognitive learning mainframe that hosts will connect to and people will feed data into. Then around 1981 or so, the PC first started to hit commercial shelves, really started by Radio Shack with its Tandy computers. Then in 82, 83, IBM released its first PC, and Apple soon followed. And we've had the personal computer, networked computer era since then. The client-server era started around the same time. And what it is, it kind of looks like the mainframe model. Mainframe is a supercomputer that remote hosts will connect into, and the mainframe does the processing. Well, in client-server, we have you, the client, and we connect to different types of servers. You look at going to any kind of website. So let's say we're going to go to maris.edu. So that maris.edu is made up of a lot of servers. The first being a web server, which holds what maris.edu is. We'll go much more into greater detail what servers are shortly. Behind maris.edu is a application server. What that does, it parses queries. A query is just a request for information to a database server. A database is where we centrally store files for indexing, quick retrieval, and for querying. So any website will have at least 3 servers: website, web server, app server, database server. The enterprise computing model is still present, where we have one source of data connected to various parts of our organization. And lastly, cloud and mobile computing. Cloud has really taken off in the last 10 years. It's where we process our day-to-day, our client-server model, all on the web. We'll get much more into cloud shortly. And here we can kind of see what we're talking about. Mainframe, the bigger computer at the top of the slide, has a bunch of hosts connected to it. Personal computers, they used to be standalone. I remember when I was an undergrad at St. John's, we just really started to get computer labs. And we would go into these rooms that are, 30, 40, PCs running off 5 1/4 dish or 3.5-inch discs. Then, probably as I was graduating, the CD came around. And that's how we access files. Back in the 80s, we didn't have big hard drives. We didn't have a lot of memory. So a hard drive is a place where we store data. Memory is a tool in a PC where we can control how quickly and how many programs we can have open at the same time. You may have heard the term processor or CPU or coprocessor. Typical vendors for those are Intel and AMD, and they really provide our calculations, how quickly we can make calculations. In client server, you can see kind of emulates the mainframe model, but we use the cloud. Between the two computers here is the cloud or the internet connected to that server. Notice, however, we look at the personal computer part of the screen, they're not networked together. Networking came some years later for data sharing, which we see here. The enterprise computing, this can model maybe one office space, one floor in an office. We have a connection to a server, the internet with routers and switches, a bunch of clients around our office space. In the cloud model, everything's enveloped in the cloud using virtualization and the speed and the availability of the internet to do connections and processing. A little better depiction of how client-server works is here. As I indicated earlier, we have a web server, an application server, a system that's stored on the application server, and our data. So we, the client, log into mymarist.edu. You click student and you go to maybe look at your transcript to date. So we send that request to the internet from our PC, our laptop, our smartphone. It gets to the web server that's hosting mymarist. It goes to an application server, which is what renders our web pages on our web server. And we pull up our transcript. We send it back all the way to us. Some drivers in technology. We really don't think about these things on a day-to-day basis, but they're good to know in a classroom. The first being Moore's Law. Computing power doubles every 2 years. It's really why I give a life cycle of our PCs I've deployed Greystone to 3 years. After the end of 3 years, the machines are pretty much not performing the way they should, and we try to replace them. The second law of mass digital storage, the amount of data being stored doubles every year. With so much available free storage online with things like OneDrive and Dropbox, we're storing probably a little more than double every year. And finally, Metcalfe's law, which is the value or power of a network grows exponentially as a function of the number of network members. Meaning, if we have a network of 2 computers, we have some value. If we have a network of 100 computers, we have much more value. There's much more sharing going on. We look at the declining costs of internet access. You can get pretty fast speed from our cable providers, 100 meg or more, starting at $40. 3 years ago, it was $200 for 100 megs. Even for businesses, the price of internet is going down. The availability is going down. We're lucky here in the United States that we have about 85% of our population with internet. Countries like Finland, Sweden, Denmark, the percentages are about 98%, really due to the small populations and high per capita income. And last, the internet is really based on a standard called TCP/IP, which is Transmission Control Protocol. That one standard alone in its development has led to cloud computing because everyone uses TCP/IP. There's other mediums across the world for delivering internet to us, but the protocol is all the same. These two slides really depict Moore's law. Power is going up, price is going down. We now get processors. Again, that's what I told you is what controls our calculations. We have 2 core processors, which is one processor that emulates 2 cores, and we have quad processors, which is one processor emulating 4 cores, which means 4 times the processing power, 2 times the processing power, all for the same cost as 1. So we can get a lot of bang for the buck. These slides are just depicting what we store and how much chips have gone down. Chips are what we talk about, memory, or our CPU or our motherboards. Back in the 1965 all the way down to 2018, we see cost about $8 to make a chip, one single chip. Now it's taken maybe 1/10 of a millionth of a chip. Of a dollar, sorry, not of a chip. Sorry, sorry guys, not thinking straight. Here we see the amount of storage per dollar rises exponentially as well. 1950 to 2016, we're storing 100 gigabytes of data where we used to store none. My first PC we had built for us had 256K hard drive on it. Now I couldn't store one picture on that hard drive. And the slides depicting the cost of internet. So the cost of kilobit internet back in 1990 or so was almost $2, and now it's almost free for that size. So what are the components of IT infrastructure? It starts with our hardware platforms. In hardware, we look at servers. Servers are simply high-end computers like your laptop, which allow connections to them. These servers have operating systems much like your laptops and phones do. Included in hardware is our laptops, our desktops, our tablets, and our smartphones. Our software applications, some which we'll talk about in chapters 9 for 12, and some we use, as part of our day-to-day. Like at Marist, currently we use Lotus Notes for our email, and for, Word, Excel, PowerPoint, we use Microsoft Office. You all more than likely will use Google's free suite of applications for all the same. We look at data management and storage. That's where we talk about databases and database management. We'll see that in chapter 8, I believe. Network and telecommunications we're going to look at next week. It's how we connect one or more devices together. We'll look at integration of internet and all it can do for us. And lastly, how we have consultants help us bring in system integration. Important to note here, A, this is probably going to be an exam question, and B, IT infrastructure is made up of our users as well. This slide really gives us a snapshot of all of what we just talked about. So I'm going to start with this orange circle for hardware platforms. Popular vendors are Dell, IBM, Oracle, HP, Apple, Lenovo. Operating systems, On servers, we use Linux, Unix, or Microsoft Windows Server 2016 for the most part. On laptops, we'll use either Windows 10 or 7, Mac OS, or the Chrome operating system from Google. On our smartphones, we use iOS or Android. Some vendors of enterprise systems are SAP, Microsoft, IBM, and Oracle. At Greystone, we're implementing an enterprise software application called NetSuite from Oracle. Networking technologies. I want you to note here that Windows Server, Linux are operating systems don't really belong in this space. Some vendors we see here are Cisco, Alta Vista, and Fortinet. There's some bigger ones. AT&T and Verizon are vendors for networking and telecommunication services. Some big consulting firms are IBM, HP, and Accenture. We can also put in cloud partners here like Amazon AWS or Flexential, Single Hop, HP, IBM Cloud, all places where we can integrate our services. Excuse me. Under data management and storage, we see a bunch of applications that hold data for us, including IBM's DB2, Oracle, SQL Server, Sybase, MySQL, AMC, Apache, and Hadoop. Hadoop is for big data. The others are for relational databases. And we can actually put Microsoft Access here as a single user database management system. And some applications to make websites include Microsoft IIS, Microsoft .NET, Unix, and Java. As we've seen already, client machines, that's who we connect to, what we use on a day-to-day, what our end users will use. Desktop PCs and laptops. Mobile computing, smartphones, tablets, wearable devices. So, again, a desktop and a laptop all start with a motherboard. And the motherboard is a bunch of circuitry. Included in the motherboard is our processor. On either one, we're going to have some type of heat sink. We kind of seen heat sink when we looked at the water cooling of servers. But what it does, it takes the heat generated from the speed at which the processor calculates and gets that off the motherboard and out of the computer itself. So if you ever wonder why your laptop is getting hot on your lap when you're using it, it's because that hot air that's generated from the processor is being removed through a heatsink. Heatsink is like a fan. We have memory, again, which controls how many programs we have open and closed at any given time. We have hard drives, which is our storage, where we store data. Oftentimes people mistake memory and hard drive. They are two distinct things. Also included are video adapters or video cards, which provide our video to our systems. We have Ethernet ports, which will connect us to an Ethernet network, which we'll look more at when we look at networking. We'll have Bluetooth adapters. We'll have USB 1, 2, and 3 adapters. We'll have HDMI adapters, Thunderbolt adapters, all of which are means to connect other devices or to communicate. Servers and mainframes are pretty much synonymous, though they have different functions. Servers, again, are high-end PCs. You can actually log into them, and they kind of look like a regular computer does. Mainframes, however, have a distinct operating system and are really used for hosts to connect into. We've seen corporate servers run by Windows Server, Unix, and Linux. Linux is a version of Unix written by Red Hat, which was just acquired by IBM. used to be free to develop and add on to. Now there's some costs associated with it. We've talked about client-level operating systems already. Google's Chrome OS simply connects to the internet and uses Google's suite of services. Android and iOS are our predominant operating systems for our smartphones. Windows 10 you see on mostly Microsoft Surface products. And lastly, Windows or Mac OS. Before I talk about enterprise software applications, I want to give you this week's question of the day. Two things. I'm going to go back to my love of college basketball. And the Marist women's team on Saturday played a pink game where it was for breast cancer. Let me know the score of that game. And also, yesterday my alma mater, St. John's, played Villanova. Let me know how many points St. John's came back from to win the game. So, totally unrelated to the course, just two things that I am quite passionate about. I use these opportunities sometimes to let you know a little bit more about me. And I believe you can see my Microsoft window here. This is presented from outside the Emirates Stadium in London. This is the shop entrance where most visitors come into, right off the Arsenal tube station, with two cannons sitting in front of it, if any of you were wondering where the picture may have been from. So enterprise software. Software that connects our entire organization. Each organizational unit that we've already talked about, HR, accounting, and finance, manufacturing, sales, marketing, IT, all connect to one single source of data with an application or a portal written around it. Largest vendors are really Oracle and IBM. Data management is how we have data management and database management systems so that we have a visual depiction of where our data is, how it's stored, what the relationships are with that data, what is the entity all about, or the noun, what are its attributes, the adjectives, how do they relate, the verbs. Some popular vendors we can see here. In my database career, was strictly SQL Server, but more people use Oracle and DB2 combined and Microsoft SQL Server. All really work off what's called structured query language, or SQL. SQL is a programming language in IT that's really based off 20 or 30 common language keywords, and queries are built from there to get data out. When I teach database management at the graduate school level, I have my students get a book called SQL in 10 minutes. It's 15 chapters. Each one takes 10 minutes. By the time you're done, you're a competent SQL programmer. If any of you have interest in how to get data from databases, I highly recommend learning SQL. When we look at networking and telecommunications, please don't look at network operating systems. It's there as a point of reference, but we're really looking at the hardware here. Cisco, Juniper, Fortinet. We're looking at telecommunication services, our cable companies, Verizon, AT&T. We're looking at how we use telephones, whether it's cell phones or using voice over IP or VoIP. And that's simply having a phone that works with the internet. The way we connect to the internet is through routers and switches. We'll learn more about routers in coming weeks, but that really connects two networks. So, and that's with with all the SOs. A funny story. I've become pretty good friends with our local priest, and he's known for saying also too. So I've caught myself saying so too much in this video, so I'm going to stop saying so. A router connects two locations, and it's really the foundation of the internet. The internet is a large wide area network connected by routers. What a switch does, it takes a bunch of client computers through a connection medium and connects it to a router. What I'll do when we get to the networking section, I'll put in pictures of a router and switch and cables into the presentation so you see what they look like. For the class that meets on Tuesday afternoons, I will bring a switch in, at least, maybe even a router. Consulting and system integration services. In IT, we leverage outside vendors often because we want to keep our core functions working properly, and we want to invest in users that work those functions. We don't really want to spend a great deal of resources on technology personnel. So we find it often easier and more cost-effective to outsource. And that's what this slide's all about. Using other vendors to integrate our infrastructure. Some current trends in IT. The use of smartphones. We've run out of traditional IP addresses because so many people use smartphones. I remember in the early 90s when BlackBerry was just, setting the stage for smartphones, I was given a BlackBerry device as a test when I worked with XL Capital, and it really changed the way I worked. It worked off a cellular service, and I had my email at all times. And now look at what we do with smartphones. Netbooks are probably a thing of the past. I use netbooks for a particular connection to a web-based healthcare management system that doesn't work with Chromebooks. But netbooks were supposed to be a cheap way to get people into a laptop-formed device. We look at tablet computers, which really displaced the Kindle. The Kindle was the first widespread used tablet. And then we look at wearable devices. A big topic in my world is bring your own device. And I guess I deleted the class discussion on it. What bring your own device is, do we allow, as an IT governance model, our employees to bring their own smartphones, laptops, tablets, etc. onto our corporate networks? I've always been a proponent against this. My personal cell phone doesn't connect to the Greystone network when I'm at Greystone. Marist doesn't give its part-time faculty devices, so my devices do connect to Foxnet. But I have a username and password for Foxnet like you all do, so it's pretty secure for me. And we actually have to put software on our bring your own devices in Marist so that they know what devices are connected to their network. Again, for me, it brings in too much security issue to manage devices that I don't own. I can do whatever with a device that I own, but you bring your smartphone and you start causing, viruses on my network. Excuse me. I can tell you to turn it off, but I can't take it and do any kind of remediation. While I'm thinking about it, I want to go back to this slide. So when we have a server-based infrastructure, we put those in a data center, whether it's a local data center or one we outsource. And I'm going to have a form question that's going to say something like, look up data centers and see what services they provide. Maybe put a picture of one up. But what a data center is, it's a place where we store a bunch of servers to allow remote connections to. It's really the foundation of cloud computing. These servers typically are very high end, and then we use virtualization tools from software vendors like VMware to take all the resources that are in a server, all its memory, its processors, and its hard drive space, and we virtually share them to make tens of hundreds of virtual servers. Also included in a data center are the racks to store the servers. A rack is like a closet. You just screw the servers in, and then we have them there easily managed. We have air conditioning, fire suppressant, alarm systems, uninterruptible power supply systems to keep us running all the time. We may have generators. We may have humidity controls. We may have the cold water cooling we've seen earlier in the semester. That's our true infrastructure to corporate servers. Not many people have data centers locally in their buildings anymore because real estate costs a lot of money, and we can really do what's called co-load or co-locate, where we store our servers somewhere else, but we still manage them. At Greystone, we use a cloud-based model for our servers. We have one physical server or bare metal server that's chopped up into 5 virtual servers that we and our vendor co-manage together. Some other trends are quantum computing. There's a quiz question: is quantum computing available to the masses? It is available to anyone who has the money to afford it. It uses quantum physics to represent and operate on data. Virtualization, I talked about already. It allows a single resource to act as many. It really gives us a better return on our investment for servers. Servers and the multitude of processors and hard drives and memory that they can have do cost a lot of money. And by buying one high-end server with a lot of resources and sharing that among 10, 20 servers that we need, I hope you can see buying one is cheaper than buying 20. So we can centralize our facilities. We can use network attached storage to even share and cut costs even more. We've talked about cloud computing already. There's a few models to cloud computing. The first is private, where all of our resources that we subscribe to are on our own network. The second is public, and you can look at public cloud as Google's suite of applications, really available to anyone. And a hybrid is where you use a mix of public and private cloud. Services we can get from cloud computing are infrastructure as a service, software as a service. So software as a service is like Google, Office 365, things like that. Platform as a service. I use disaster recovery as a service. And anything you can really think of, we can have as a service. So buying things as a service on how much we consume rather than buying outright will really let us save some of our capital for other projects. This is what cloud computing looks like. Remember, the cloud represents the internet. We have phones, laptops, servers, desktops, and tablets all addressing our cloud environment. We have enterprise software, we have content management, we have database management, we have disaster recovery services, we have our compute and our network management, all under our friend the internet. And Amazon Web Services is one big cloud provider. You think of Amazon as strictly a shopping site, but it's the biggest cloud provider and biggest outsource partner that there is, bigger than IBM Cloud. we have application services, management. We can do analytics off of data warehouses. Computing means infrastructure as a service, which means providing those virtual servers we talked about. We have networking. Should also be security as well as networking. We have content delivery, data storage, database storage, and the like. Some other trends, some we've seen in the videos the first week of class, are green computing. That's reducing our consumption in our data centers. If you have a building that's strictly a data center, we're having a lot of load for electricity, heating, cooling, and we look for means to be smarter with how we heat and cool and provide electric to these locations. We can use chilled water from oceans. We can use solar energy. We can have plants on top of our data centers to provide relief from the sun and produce a crop or give back oxygen to the environment. We can reuse water that we use to cool our facilities. We've talked about Linux already. It's open source, available to a community of programmers. Now owned, primary driver in Linux is a company called Red Hat, now owned by IBM. But there's still a version of Linux that's not IBM owned. Websites are made off of languages. Primarily HTML or hypertext manipulation language, or Java. Java is an Oracle product. Some programming languages are Ruby, Python, not listed as .NET or Visual Studio.NET from Microsoft. We don't need to discuss web services, service-oriented architecture. We've talked about software outsourcing and cloud services already. We can acquire software in a few ways. First of all, we can develop it. It costs thousands or millions to self-develop software. Plus, you need to have the staff that has the skill and knowledge to be able to deliver software applications. The second one that's used primarily is we buy a solution out of the box and change our business processes to match that application, and we deploy it. Last, we can get software as a service, which we use an outsourced model with service and it's software on the internet. Meaning, I look at NetSuite. It's a website run by Oracle, serviced by Oracle employees that we connect into. So not only is it a software as a service that it's all web-based, who's managing that on the back end, Oracle, is outsourced. So our spend would be the equivalent of the Cayenne and the red line for that one application. How do we deal with change? IT has to be scalable. We see in the ESPN video where their Score Center application has to be able to scale up or down based on viewership. We scale up during the Super Bowl. We scale down in February when there's really only basketball and hockey going on. Maybe we scale down in August, July when there's only baseball going down. So who controls IT infrastructure? Well, it's really twofold. Remember my discussions on how IT has to be firmly integrated in the organization. That would mean all C-level employees should control IT infrastructure. Managed by a chief technology officer if one is available, or the chief information officer, or his or her delegate. How do we organize IT? We do it in a few ways. A centralized approach where we have one ID department that makes its decisions. Okay. Or a decentralized approach where business unit ID departments make their own decisions. I'm a believer if it can be managed between time zones and locations that a centralized approach is a benefit. That's what we used at Excel Capital. We had a program called One Company Without Borders. We had our IT centralized in Hamilton, Bermuda, and direction to all subsidiaries came from that one entity. While my wife Melissa's organization Geodas uses a decentralized approach to IT, where each business unit, each organization under the Geodas cloud has control over its own IT. So we lack any kind of standards or true governance. It works kind of for them. They could be much better if they centralized their IT. Probably not in their home country of France, but here in the U.S. Who's responsible for IT costs? It should be shared through the entire organization and its organizational units. If you've built out your general ledger appropriately, if not, IT will get a budget and have all costs associated to them. How do we invest in technology? Conundrum every day for me, especially at Greystone. When I was at Excel Capital in Syncora, we never bought IT infrastructure. We leased it. At the end of our lease, we either did a dollar buyback, that's the approach for leasing we did, or we sent it back to the leasing company and provided new. We would do 3-year leases for the life cycle of our equipment. It freed up capital for us to do other things, and we didn't have to invest so much up front. At Greystone, however, we get our funding from the state, and we typically buy our equipment. We leased for one set of purchases last year, and it's kind of hard to budget when for a nonprofit funded by the state in that we've already deployed something, we still have to pay for it. So we've scrapped our leasing model at Greystone in order to buy. It's a lot more capital we have to give out, and actually my budgets have been cut so much this year where leasing would have been a better option, but it's not something we felt like going forward with. As we discussed already, outsourcing is a key driver in infrastructure. More often than not, we're going to hire someone to manage our infrastructure for us. And lastly, more and more people, including us at Greystone, have moved to the cloud. So we really have centralized management through web portals rather than physical touching of appliances. You'll have a total cost of ownership question within the chapter for this week on dirt bikes. It really looks at what do we really spend for a computer. So way back in the day, I used to sell computers for a company called Circuit City when I was teaching and running the Millbrook Schools network. And our bosses would always try to have us sell the warranty. So if I were selling someone a computer back then for $2,000 and they bought the warranty for $400, their total cost of ownership was $2,400, plus how much time or effort they spent to install the stuff at their home, get training and support and the like. Same thing in business. We look at how much something costs, plus its installation costs, maintenance costs, downtime, etc. We have much lower total cost of ownership when we use cloud services. Our competitive forces model that we've seen with Porter is the same here. We have market demand for our firm services. We have to look at our firm's business strategy, how that plays into account what we spend. We have to look at our IT strategy, we have to look at our IT needs. First thing I did at Greystone when I went in after interviewing its people was looking at its technology and building a roadmap saying, here's what is needed. We should look what our competitors are doing, not only in the service we compete with them for, but in how they handle IT. All right, guys, so that's it for this week. I will get this posted and you all notified as soon as possible. Thanks, and we'll see you next time.